Hello everyone, I am Pavitra Devi, working as Assistant Professor in Department of Computer Science, Artificial Intelligence and Data Science in Dr. S. Rajeshwari College of Arts and Science. Now I am going to take the class about the synchronization hardware. First, what is synchronization hardware? Many systems provide the hardware support for the critical section code. Process synchronization problem occur when two processing running concurrently share the same data or same variable. The value of the variable may not be updated correctly before it being used to second process. Such the condition is known as stage condition around the condition. There are software as well as hardware solution to this problem. In this article, we will talk about the most efficient hardware solution to process synchronization problem and its implementation. Many systems provide hardware support for the critical section code. The critical section problem could be solved easily in the single processor environment if we could resolve interrupts to occur while the shared variable or resource is being modified. In this manner, we could be sure that the current sequence of the instruction would be allowed to execute in order with preemption. Unfortunately, this solution is not feasible in a multiprocessing environment. Disabling interrupt on a multiprocessor environment can be either time consuming as the message is passed to the all processor. This message transmission lag delay entry or thread into the critical section and the system is efficiently decreased. The critical section problem could be solved simply in the single processor environment if we could prevent the interrupt from the occurring while the shared variable was being modified. Next one, algorithms in the hardware approaches. There are three algorithms in the hardware approaches of solving processing generation problem. First one, test and set, swap and then unlock. Hardware instruction in many operating systems help in effective solution of the critical section problem. The test and set. Here the shared variable is log and initialized to the false. The test and set log algorithm work in this way. It always return whatever value it send it and set log to the true. The first processor will enter into the critical section at once as the test and set log will be written false. It will be break out of the while loop. Other process cannot be entered now as log. The set is true. So the while the loop is continued to be the true. Mutual exclusion is ensured once the first process gets out the critical section, the lock is changed to false. So now the processor can enter one by one. The process also ensured, however, the first process and any process can go on. There is the queue maintained. So many processes that find the lock to be false again and enter. So bounded waiting is not ensured. Second one, swap. Swap algorithm is a lot like the test and set algorithm. Instead of directly setting lock is true in the swap function. Key is set to true and then swapped with lock. First process will be executed and while key since key equal to true, the swap will be the placed, hence lock is to true. Next one, unlock the lock. Unlock and lock algorithm use the test and set to regulate the value of lock, but it add the another values for each processor while check whether not processing has been waiting, as the ready queue is maintained with respect to the process in the critical section. All the process coming in the next added to the ready queue with respect to their process number are not necessary sequentially. Next one, mutex law. The hardware-based solution is complicated, so generally inaccessible to application program. Instead of operating system, designers build the software tools to solve the critical section problem. The simplest of this tool in the mutex log. The mutex log for the critical section problem presented synchronization hardware. The mutex log to protect the critical section and thus prevent the race condition. That these approaches must acquire the log before entering the critical section. It releases the unlock when it exits the critical section. The acquiring function acquires the log and the release function releases the log. A mutex log has been boolean variable available. Those values indicate if the log is available or not. If the lock is available, call to acquire succeed. Otherwise, the lock is considered as the unavailable. Next one, semaphore. What is semaphore? Semaphore is an integer variable which upon the initialization is accessed only through the two standard atomic operation. One for wait, another one for signal. Wait was originally terminated as the P. Performed to test. Signal was originally terminated as V. The operation wait and signal are atomic, which means if the process P1 execution after their wait and signal, there is no process can prompt P until it finish wait and the signals. Next, usage of the semaphore. Semaphore are the two types, binary and counting. In the binary semaphore, the value of S can be zeros or ones only. An alternative name of the binary semaphore is mutex log because they provide mutual exclusion. Binary semaphore is used when there is only one instant of the resources. Hence, the semaphore can have two values, one for free, another one for zero is DC. Counting semaphore is used when there are multiple instances of the same resources. For example, there are 5 printers. This means there are 5 instances of the resources. Printer now 5 process can simultaneously print. So the initial value of the semaphore or the variable should be 5. That is equal to the number of instances available. Thank you.